Hello everyone, I am Meena Kumari, PGT Chemistry from Government Model Sanskriti Senior Secondary School, Morni Hills. Today we'll do Class 11th Chemistry, Chapter Name Hydrocarbon, Part 3. Unit 13, Hydrocarbon. We are going to cover chemical property of ethane and conformation of ethane. Now, let us start with the chemical property of alkanes. First is substitution reaction. सब्स्टिट्यूशन रिएक्शन वो होते हैं जिनमें कि एल्केन के हाइड्रोजन्स एटम्स दे आर सब्स्टिट्यूटेड बाय सम अदर ग्रुप. So we can say that one or more hydrogen atom can be replaced by either halogen, nitro group or sulfonic acid group. Now, under substitution reaction, we will study halogenation. Now, halogenation take place at higher temperature or in the presence of diffuse sunlight, or you can say UV light. Let us study the rate of a reaction of alkane with halogen. So, when we compare all the halogens, fluorination is too violent reaction and iodination is very slow reaction. So, when we compare these, the F2 will be more reactive and then the Cl2, then Br2 and then the lastly is I2. Now let us consider the rate of replacement of hydrogen of alkanes. So 3 degree, that is tertiary, will be more than the secondary, that is 2 degree, which will be more than the 1 degree, that is primary. Now let us study the halogenation in case of methane. So CH4 is methane when it is halogenated, that is chlorinated, Cl2 in presence of H nu. This one of the chlorine atom replace the hydrogen atom and will get CH3Cl, that is chloromethane plus HCl. This chloromethane, when again chlorinated in presence of H nu, then one of the hydrogen atom of this is replaced by the chlorine and will get CH2Cl2, dichloromethane plus HCl. Now, when this CH2Cl2 is again treated with Cl2 in presence of H nu, this hydrogen atom is replaced by the chlorine and we get CHCl3, that is trichloromethane plus HCl. This trichloromethane again on chlorinated and in presence of H nu will replace this hydrogen atom and will get CCl4, that is tetrachloromethane plus HCl. Let us study the mechanism of halogenation. First step is initiation. In initiation, homolysis of chlorine molecule take place in the presence of light and heat. Homolysis means the bond which consists of two electrons. The one of the electron shifted to one chlorine atom and the other electron shift to the other chlorine atom. So both free radicals are formed because they contain one electron. And the Cl-Cl bond is weaker as compared to CC bond and CH bond. Hence, it is easier to break. Second step is propagation. In propagation, chlorine-free radical attack the methane molecule to generate the methyl-free radical. So in this step, chlorine, when attack this methane molecule, it forms HCl plus methyl-free radical because this radical contain one electron. Methyl group contain one electron. Now, methyl radical thus obtained attack the second molecule of chlorine. So this methyl radical which is formed in the first step is again now attack the chlorine molecule to form CH3Cl. with the liberation of chlorine-free radical. So in this step, we'll get the chlorine-free radical along with the formation of CH3Cl, that is chloromethane. Last step is termination. The reaction stops after some time due to the consumption of reactants. जब reactants खत्म हो जाएंगे तो reaction stop हो जाएगा और due to the following chain termination steps. That is when two chlorine free radical combines to form a chlorine molecules, and when chlorine free radical combine with a methyl free radical they form CH3Cl, that is chloromethane. And last step is when both the methyl free radical they combine to form a ethane. So all these three steps result into the chain termination. Though CH3Cl, the one of the product is formed, but free radical are consumed and the chain is terminated. Let us start with the second chemical property, that is combustion. Combustion क्या होता है? जब किसी एल्केन को हम एयर और डाइऑक्सीजन के प्रेजेंस में कंप्लीटली ऑक्सीडाइज करते हैं और वो फॉर्म करता है कार्बन डाइऑक्साइड और वाटर, that is H2O, or large amount of heat is liberated. So such reaction is called combustion. General combustion equation for alkane is, alkane का जनरल फॉर्मूला हमें पता है, CnH2n+2 होता है. ये 3n+1/2 ऑक्सीजन के साथ कंबाइन होता है और NCO2 plus n+1 H2O फॉर्म करता है. Now methane, that is CH4, when combined with 2O2, it gives CO2 plus 2H2O. Or incomplete combustion of alkane means that when we heat the alkane in insufficient amount of air and dioxygen, a carbon black is formed. That is, CH4 when treated with O2 in the limited amount of oxygen, that is called incomplete combustion, will get carbon black. And that is used in the manufacturing of ink, printer ink, black pigments, and as filters. Let us start with the third chemical property, controlled oxidation. Alkane on heating with the regulated supply of dioxygen or air at high pressure and in the presence of suitable catalyst give a variety of oxidation product. मतलब जब एल्केन को हम डाइऑक्सीजन और एयर के प्रेजेंस में हीट करते हैं, प्रेशर हाई होता है और कैटलिस्ट के प्रेजेंस में हीट किया जाता है इसे, तो हमें वैरायटी ऑफ ऑक्सीडेशन प्रोडक्ट मिलते हैं. दैट इज व्हेन मीथेन ऑन ऑक्सीडेशन इन द प्रेजेंस ऑफ कॉपर एट 523 केल्विन एंड 100 एटमॉस्फेयर विल गेट मेथेनॉल. अल्कोहल बनाता है ये. तो मीथेन alkane is converted into alcohol on oxidation. Now, when CH4 is oxidized in presence of MO2O3, we'll get aldehyde, that is methanol, HCHO, along with water. When ethane is oxidized in presence of manganese diacetate, we'll get acid, that is ethanoic acid, along with the formation of 2H2O. Fourth chemical property, isomerization. An alkane on heating in presence of anhydrous aluminium chloride and hydrogen chloride gas isomerize to branch chain alkane. जब हम alkane को heat करते हैं अनहाइड्रस AlCl3 और HCl के प्रेजेंस में, तो ये ब्रांच एल्केन बनाता है. दैट इज आइसोमर इज फॉर्म. सो लेट अस टेक एन एग्जांपल ऑफ N-हेक्सेन. N-हेक्सेन ये आपका N नॉर्मल हेक्सेन है जिसमें कि सभी कार्बन स्ट्रेट चेन में है. अब जब इसको एल्यूमिनियम क्लोराइड और HCl के प्रेजेंस में हीट करते हैं तो क्या होता है? इट फॉर्म्स एन आइसोमर। एक बनता है 2-मिथाइल पेंटेन और दूसरा बनता है 3-मिथाइल पेंटेन। नेक्स्ट इज aromatization. When an alkane having 6 or more carbon atom और उनको हीट करते हैं 773 Kelvin at 10 to 20 atmospheric pressure in the presence of oxide of vanadium, molybdenum, chromium are supported on alumina gel get converted into aromatic compound और इस रिएक्शन को हम बोलते हैं aromatization. Now this is N-hexane when it is treated with the oxide of vanadium, chromium and molybdenum at 773 Kelvin and 10 to 20 atmosphere. ये जो N-hexane है वो aromatic compound बनाता है, that is benzene. और इसी रिएक्शन को हम aromatization कहते हैं. Our next chemical property is reaction with steam. When methane is treated with steam in the presence of nickel as a catalyst, it forms carbon monoxide and dihydrogen. That is, when CH4 is treated with water that is in the form of steam in the presence of nickel, it forms CO plus 3H2. Our last chemical property is pyrolysis. That is, decomposition reaction of higher alkane on heating to high temperature result into smaller fragment is called pyrolysis or cracking. यानी जब हम हायर एल्केन को हीट करते हैं हाई टेम्परेचर पे तो डिकम्पोजिशन रिएक्शन होता है और ये छोटे छोटे फ्रैगमेंट में बढ़ जाता है और इसी को हम क्रैकिंग या पैरालिसिस कहते हैं. Let us consider an example of hexane, that is C6H14. When on heating at 773 Kelvin, the pyrolysis or cracking take place and it result into the formation of different fragments. That is, it can form C6H12, that is hexene plus H2. It can also form butene plus ethane. It can also be converted into propene plus ethene plus methane. Let us study now conformations. तो conformation क्या होती है? जो different arrangement होती है atom की in a molecule which can be obtained by the rotation of carbon-carbon single bond, and these are called conformation or conformer or rotamer. Now let us start with the conformation of ethane. In ethane molecule, one carbon atom is stationary and rotate the other carbon atom around the carbon-carbon axis. ये rotation जो होता है it result into infinite number of spatial arrangement of hydrogen atom attached to one carbon atom with respect to the hydrogen atom that is attached to the other carbon atom, and these are called conformational isomer. तो conformational isomer क्या होते हैं? जो हमें डिफरेंट इनफाइनाइट नंबर ऑफ आपकी स्पेशल अरेंजमेंट मिलती है और वो कैसे मिलती है? जब हम हाइड्रोजन एटम दैट इज अटैच्ड टू द वन कार्बन एटम, ठीक है, इज रोटेट with respect to the hydrogen atom that is attached to the other carbon atom, तो उससे हमें infinite number of arrangement मिलती हैं. उन arrangement को हम conformational isomer कहते हैं. Now, they are staggered conformation and eclipsed conformation. Now, staggered का meaning क्या है? In this arrangement, hydrogen atom of two carbon atom are staggered. मतलब they are far away from each other with respect to one another. They are the maximum apart and hence minimum repulsion between them. ये दूर दूर होते हैं इसीलिए इनमें repulsion भी कम होता है. Eclipse conformation क्या होती है? जहाँ की the hydrogen atom of one carbon atom are directly behind those of the other. एक कार्बन के एटम का जो हाइड्रोजन होता है वो दूसरे कार्बन के एटम के हाइड्रोजन के बिल्कुल नजदीक होता है और उस वजह से रिपल्शन भी ज्यादा होता है एंड as compared to the staggered conformation. Now, eclipse and the staggered conformation can be represented by, ये दोनों ही conformation आपका कैसे represent की जा सकती हैं? By Sawhorse projection or by the Newman projections. Now, let us start with the Sawhorse projection. इस projection के अंदर molecule is viewed along the molecular axis. That is, we view along this axis CC. The central CC bond is drawn as a straight line. आप देख सकते हैं एक ये straight line द्वारा आपको बनाना है. And this is slightly tilted to the right. ठीक है, और ये right की तरफ slightly tilted होता है. और जो front carbon होता है आपका as the lower left hand carbon. ठीक है, and the rear carbon जो कि पीछे वाला कार्बन है is shown as the upper right hand carbon, and the three bonds around each carbon atom are shown in by the three lines as you can see in these pictures. Eclipse में आपका जो bonds है ये CH bond जो होता है फर्स्ट कार्बन यानी फ्रंट कार्बन का और CH bond जो रेयर कार्बन का है वो दोनों एक दूसरे के बहुत ही नजदीक होते हैं तो इनमें रिपल्शन की चांस ज्यादा होती है. और स्टैगर्ड के अंदर ये बॉन्ड आप देख सकते हैं दे आर फार अपार्ट और रिपल्शन जो होता है वो इनमें कम होता है. सेकेंड इज अवर न्यूमैन प्रोजेक्शन. In this method, the molecule is viewed from the front along the carbon-carbon bond axis. और जो दो कार्बन एटम है that is form the sigma bond are represented by two circle. और जो दो कार्बन होते हैं इथेन के उन्हें दो सर्कल से हम दर्शाते हैं. One behind the other. एक कार्बन के पीछे एक कार्बन होता है. So that the only front carbon is seen. And the front carbon atom is shown by a point. और जो पहला जो कार्बन होता है फ्रंट कार्बन जिसे हम कहेंगे उसे पॉइंट से दर्शाते हैं. Where the carbon atom which is further from the eye is represented by the circle. और जो हमारी आंख से दूर होता है उसे हम सर्कल से दिखाते हैं. Therefore, the CH bond in the front carbon are depicted from the center of the circle. और जो CH bond होते हैं आपके वो फ्रंट कार्बन के सेंटर ऑफ सर्कल से दिखाए जाते हैं और जो बैक कार्बन होता है उसके जो CH बॉन्ड है वो उसके सर्कल के सरकमफ्रेंस से दिखाए जाते हैं एंड दे आर एट एंगल ऑफ 120 डिग्री ईच. दो तरह की आपकी फॉर्म्स बनते हैं न्यूमैन में भी, एक इक्लिप्स कन्फॉर्मेशन और एक आपका स्टैगर्ड. इक्लिप्स के अंदर आप देख सकते हैं कि जो CH बॉन्ड है दे आर वेरी close to each other, hence repulsion is maximum. And in case of the stagger, the CH bond are far apart from each other. Let us start with the relative stability of the conformation of ethane. The two conformation of ethane differ in their relative stability. In staggered conformation of ethane, the electron cloud of the CH bond are as far apart as possible. यानी अगर हम स्टैगर्ड कन्फॉर्मेशन इथेन की देखते हैं तो उसमें जो CH बॉन्ड के इलेक्ट्रॉन क्लाउड हैं वो एक दूसरे से बहुत दूर होते हैं. The staggered conformation has minimum repulsion between the hydrogen atom attached tetrahedrally to the two carbon atom. और दूसरी ओर इक्लिप्स कन्फॉर्मेशन के अंदर इलेक्ट्रॉन क्लाउड ऑफ द CH bond are closer to each other and therefore this has the maximum force of repulsion between the hydrogen atom. और इसी वजह से स्टैगर्ड कन्फॉर्मेशन more stable होती है as compared to the eclipse conformation. So when the staggered form changes into eclipse form, the repulsion forces increases and the molecule will possess more energy and thus lose stability. In this diagram, you can see that when we draw energy versus the rotation about carbon-carbon bond, the staggered form, which is more stable, is converted into the less stable eclipse form, and this possesses the more energy as it loses stability, and the repulsion force increases in the case of the eclipse conformation as compared to the staggered form. Now these repulsive interaction between the electron cloud which affect the stability of a conformation is called torsional strain. So in case of the eclipse conformation, the strain is more because the repulsive interaction of the electron cloud is more, and the magnitude of the torsional strain depend upon the angle of rotation about कार्बन-कार्बन बॉन्ड. और ये टॉर्शनल स्ट्रेन का जो मैग्नीट्यूड होता है वो किस पे डिपेंड होता है? एंगल ऑफ रोटेशन अबाउट कार्बन-कार्बन बॉन्ड के. एंड दिस एंगल इज कॉल्ड डायहेड्रल एंगल और द टॉर्शनल एंगल. Now, based on the topic taught, let us do the assignment. How will you convert methane to methanol, methanol and chloromethane? Second question, what happens when N-hexane or hexane is treated to 773 Kelvin at 10 to 20 atmospheric pressure in the presence of oxide of vanadium? And second, methane react with steam in the presence of nickel catalyst. And third question, define conformation, explain conformation of ethane. Thanks.